Let's talk about simple harmonic motion. So I've got a question with me here. The question is saying a horizontal block spring system with the block on a frictionless surface has a total mechanical energy of 47.0 joules and a maximum displacement from the equilibrium of 0.24 meters. Part A, what is the spring constant? Part B, what is the kinetic energy of the system at the equilibrium point? Part C, if the maximum speed of the block is 3.45 meters per second, what is its mass? Part D, what is the speed of the block when its displacement is 0.160 meters? Part E, find the kinetic energy of the block at x is equal to 0.160 meters. Part F, find the potential energy stored in the spring when x is equal to 0.160 meters. Part G is saying, suppose the system is released from rest at x is equal to 0.24 meters on a rough surface so that it loses 14.0 joules by the time it reaches its first turning point. After passing the equilibrium at x equals to 0, what is its position at that instant? Okay, so the most important thing, we need to come up with a free body diagram. Okay, so we have got our spring. So if this happened to be our spring, and let's say this is going to be our equilibrium position. Now, we know that when you're dealing with simple harmonic motion, at equilibrium position, x is always 0. Now, if x is 0 at equilibrium position, then that is where we are going to have the maximum velocity. So if x is 0, we don't expect to have potential energy because we know that elastic potential energy is given by the formula k half kx squared. So if x is 0, potential energy is what? Is 0. Okay, so if we have got the maximum velocity, meaning that we expect to have kinetic energy at its maximum position. Now, the moment when we reach at its maximum position, where we are going to have the maximum of x. Now, when x becomes the maximum, then this x is same as what? It's same as a. Okay, so at this level, or at this point, you are going to discover that we are expecting to have the velocity to be 0 because it is not released yet. Okay, so the velocity is 0, but we expect to have the maximum acceleration at that particular point. So if the velocity is 0, we don't expect to have kinetic energy. So kinetic energy at that particular point is going to be 0. Then we expect to have what? Since we have the x, meaning we expect to have potential energy at its maximum position. Okay, the same thing which is happening at this point is the same thing which is going to happen when you compress the spring. So this point here, we are going to have the same part here. Okay, now there's what we call conservation of energy in a spring. Okay, so the conservation of energy in a spring, we need to know that the mechanical energy initial has to be equal to mechanical energy final. Okay, now what I mean here is since we are talking about elastic potential energy, but in other cases we are going to discover that we are going to have gravitational potential energy as well. Okay, but in this case we don't expect to have gravitational potential energy because we don't have the height. So meaning that this mechanical energy is supposed to be the sum of kinetic energy plus the elastic potential energy. Okay, meaning that this mechanical energy has to be equal to the sum of kinetic energy plus elastic potential energy. Now, mechanical energy is given by the formula half Ka squared, where A is the amplitude. Okay? Then, this kinetic energy is always half mv squared. Then, elastic potential energy is always what? Is always half kx squared. So this is the formula for conservation of energy in elastic in spring, in short. Okay, that is the formula which we have. Now, in this case, we have already been given this value, the value for mechanical energy to be this part here. We have 47.0 joules. Okay. Now, the first question is asking us to find the what? The first question is asking us to find the spring constant. So since we have the value of the mechanical energy, we are going to say that this mechanical energy has to be equal to, we have the kinetic energy which is half, then m v squared. Okay, and then we are going to have what? We are going also to have plus, we have half, which is elastic potential energy, kx squared. Now remember, the question is asking us to say when it was passing at the maximum position. Okay, so at the maximum position the velocity is zero. I said if this is my spring, the moment I reach at the maximum position the velocity is always zero. So if the velocity is zero, meaning this part here is going to be zero, meaning my mechanical energy is going to be equal to this. So I can plug in the value for mechanical energy as 47. Okay, has to be equal to, I have got this, I want to find k, then the x value we have been told that is 0.24. So I'm going to put 0.24, I square it. Okay, so what answer are we going to get? So there we go. We can just do times 2 the whole of this equation, or we just do this in simple terms. We are going to say, we get our calculator and then we say 0.24 squared. I'm getting 0.0576. This has to be divided by 2 because that is half. Okay, then I'm getting 0.0288k. We divide both sides by 0.0288, even this part by, this is 47, so we have 0.0288. Okay, so what is our k value? So I have 47 divided by 0. What? Divided by 0.0288. So I'm getting my k value as 1631.94 Newton per meter. So this is my spring constant. Okay, so if that is my spring constant, let me just put it here. Okay, now get rid of this. So that happened to be my spring constant as 1631.94 Newton per meter. That is my spring constant. Okay, then part B is asking us to find, they are saying what is the kinetic energy of the system at the equilibrium position. Now at equilibrium position x is always 0. So from this formula which we have here, this is the formula which we have, this is our formula. So if we are at equilibrium position, meaning we expect this part to be 0 because x is 0, meaning that this formula is going to be mechanical energy is going to be equal to the what? The kinetic energy. Okay, it's going to be equal to the kinetic energy. So mechanical energy is 47 joules, meaning the kinetic energy is going to be the same. So kinetic energy is also 47 joules. So our kinetic energy is going to be equal to 47 joules. Okay, we go to part C. But C is saying if the maximum speed of the block is 3.45 meters per second, what is its mass? Now, the moment when you hear the word maximum, so we're talking about the maximum velocity. So where can we find the maximum velocity? If you have got a spring, the maximum velocity you can only find it at equilibrium position. So at equilibrium position, that's where we're going to find the Vmax. So if this is the Vmax, that's where x is equal to 0, meaning we don't expect to have elastic potential energy. So this part is going to be cancelled as well. So we're going to have this. We are going to have our formula, which is mechanical energy is going to be equal to the kinetic energy plus elastic potential energy. So at equilibrium, at maximum velocity, the kinetic energy is going to be 0 because x is 0. Then we are going to have mechanical energy is equal to the kinetic energy, which is half mv squared. Our goal is to find the mass. Okay, we can just do times 2 this formula so that we get rid of half this side. We are going to have 2 me is going to be equal to mv squared. We divide both sides by v squared, both sides by v squared. So our mass is going to be equal to 2 m mechanical energy times v squared. Let's plug in the values. Okay, so if we are to plug in the values here, we are going to see that this is going to be 2 times the mechanical energy is 47. Okay, everything divided by 3.45. Now we square it. So what are we getting? Okay, so we have 2 times 47. I'm getting a 94. 94 divided by 3.45, I square it. So I'm getting my mass as 7.897. So I'm getting my mass as 7. Okay, I'm finding 7 point what? I'm finding 7.897 kgs, which is just basically the same as 7.9 kgs. So this is our mass. Okay, let's go ahead and find D. So part D is saying we need to find what is the speed of the block when the displacement is equal to 0.60. Okay, so let's just get rid of this. So remember, we have found our mass. Okay, so that mass to be what? Let me just put it here. We have found our mass to be 7. Our mass to be 7.9 kgs. Let's get rid of this. Now we are trying to find the what? The velocity. Okay, we want to find the velocity when x was equal to 0.160 meters. So first thing, we light the conservation of energy in a spring, which is the mechanical energy has to be equal to the kinetic energy plus elastic potential energy. So we know the value of this one already, so we can say we want to find what? Our goal is just to find the velocity, which is the speed. So what we need to understand here is that we are going to write the formula half mv squared plus half kx squared. Okay, so now what we need to understand here is that our goal is to find the velocity. I can shift this part here to go to the other side. So I'm going to say that the mechanical energy is going to be minus this half kx squared has to be equal to half, then we are going to have mv squared. Our goal is to find the velocity. Now for me to get rid of this half, what I should do is I can just do times 2 everywhere here so that I get rid of what? Of half. So 2 times this mechanical energy, I'm going to get 2 mechanical energy minus this half will go with the 2. I'm going to have kx squared has to be equal to mv squared. We divide both sides by the mass, we divide both sides by the mass. Okay, meaning that my v is going to be equal to what? My v squared is going to be equal to 2 mechanical energy minus kx squared, everything divided by mass. So we get the square root both sides. Okay, we get the square root both sides. What are we going to have? So if we are to get the square root both sides, we are going to get that this v is going to be equal to the square root over 2 mechanical energy minus kx squared divided by the mass. Let's plug in the values now. Okay, so we plug in the values. We are going to find that V is going to be equal to, we have this 2 times 47, I put them in brackets, minus the K is the same. The K we found, which is the 1000, this K which we have there, 1631.94 times the X value. We have been told that the X, so we can put this one in brackets, the X is 0.160. We square it. Okay, everything divided by the mass is what? The mass is just basically 7.9. Okay, so let's get our calculator. So what are we going to have? So I want first to do the top part. We see what we're going to have. So we have 2 times 47. I'm getting 94 minus, then I'm going to put these two guys in brackets, open the brackets, 1631.94 times 0.16. Now I square it, then I close the brackets. So on top there I'm getting 52.2222. Okay, that is what I'm getting. Now that one I need to divide it by what? I need to divide it by 7.9. So divide this one by 7 point what? 7.9. Okay, I divide it by a 7.9. I'm getting 6.6104. Then I get the square root of this answer. So I'm getting 2.5. Okay, I'm getting 2.5. So you can do it and confirm if you're also getting 2.5. So I'm getting 2.57. So my velocity is 2.57 meters per second. Okay, so that's part D. Let's go to part E. Part E is asking us to find the kinetic energy of the block at x is equal to 0.160. Okay, so we know that the same formula, mechanical energy has to be equal to the kinetic energy plus the elastic potential energy. So we want to find the what? We want to find the kinetic energy. So we are going to say that mechanical energy has to be, I'm going to shift the elastic potential energy to the left hand side, has to be equal to kinetic energy. So I know that this is 47 minus, this is half, K is 1, this is half kx squared, that is elastic potential energy, has to be equal to kinetic energy. So 47 minus half, we have the K as 1600 or 1631.94, and then times the displacement is 0.16. Now we square it. Okay, has to be equal to kinetic energy. So our kinetic energy is going to be equal to, okay, so we have let me first find the one which is elastic potential energy. So I'm going to say 1631.94 times 0.16, I square it, then this divided by 2 because that is same as times 0.5. Okay, then I'm getting 20.8. So this minus 47, and so 47 minus what I'm getting there. Okay, so 47. So I'm getting my answer to be 26. Okay, I'm getting my potential, my kinetic energy as 26.11, or 26, not 27. 26.11 joules. So that is my kinetic energy. Okay, so let's go to F. So we have our kinetic energy as 26.11 joules. Let's go to part F. So part F is asking us to find what? Is asking us to find is saying find the potential energy stored in a spring when X is equal to. So we want to find the potential energy. Okay. So how do we find the potential energy? Using the same one. Using the same one, we need to find the potential energy. So what are we going to say? So we know that we are going to say the mechanical energy, this formula doesn't change, is equal to kinetic energy plus elastic potential energy. Okay, so our goal is to find elastic potential energy. What are we going to do? But this one we can do it direct, because we know that elastic potential energy is equal to half kx squared. Why can't we use this one? We can't use this one because we have not been told the what? The value of what? The kinetic energy. But you can also use the same one and use the value of kinetic energy, the kinetic energy which you have found as 26.11. Okay, then you are going to discover that your answer, the potential energy, is going to be the same as using this formula. So let's do both. So we can use either this formula, because in part E we were told to say the x was the same as 0.16. So even here we are dealing with the same x, meaning the answer is going to be the same. Okay, so let's see. So what is, we have half 1631.94 times the x 0.16 I squared. Okay, so I get my calculator, I punch, I'm getting 20.9 joules. Okay, so even if I use this formula, I'm supposed to get the same answer, because the velocity, I'm supposed to use the same velocity. So since we have our kinetic energy, in short, we have the mechanical energy at 47, then it has to be equal to, we know that our kinetic energy, we have found here that it was 26.11, has to be equal to, plus elastic potential energy. Let's shift this guy to the other side. We're going to see that it's going to be 47 minus 26.11 has to be equal to elastic potential energy. So if I do the math there, I say 47 minus 26, 47 minus 26, 26.11. Yeah, I'm getting my potential, elastic potential energy as 20.89, which is the same as 20.9 joules. Okay, so we are getting the same answer. Okay, let's see our last question, which is a G. So G is saying, suppose the same system is released from rest at equilibrium. Okay, let me read again. The question is saying, suppose the system is released from rest at x is equal to. So let me just get rid of this. I create space. They are saying that suppose the system is released from rest at x is equal to 0.24 meters on a rough surface, so that it loses 14.0 joules by the time it reaches at its first turning point. After passing equilibrium at x is equal to 0, what is its position at that instant? So just before it reaches at the equilibrium, what was the position? What is the x value? Now, we need to understand to say the total mechanical energy was what? Was 47 joules. But we have been told that here they are saying that suppose the same system released from rest at x is equal to 0.4 on a rough surface, so that it loses 14 joules. So we are supposed to know the energy which was there, because 14 joules was being lost. So we are supposed to say 47 joules minus 14 joules. We see the energy which was remained. Okay, so now we are going to say that 47, what is 47 minus 14? So it is 33. So this 33 joules is now our new mechanical energy, because 14 joules was being lost. Now what was the original, what was the what? The position at that instant. Okay, so now we want to find the position. We want to find the position. We do know that at this point we are going to say that the mechanical energy is going to be equal to, or let me say the potential energy. We know that the potential energy is given by this guy. So our goal is to find the what? The X value. Okay, so 14 joules was being lost, meaning we are remaining with what? 33 joules. So this mechanical energy is going to be equal to what? The potential energy. That's why I'm using this formula dialect. Okay, I'm using this formula dialect. Now at this point now we need to understand that we are going to have we know we have this part here, this energy, the total energy. Okay, or if you don't want to think in that manner, you can say that we know that our formula is this, is equal to the kinetic energy plus the elastic potential energy. Okay, now we are saying that we are going to discover to say, since we don't have the velocity, it was released from rest. When they say it was released from rest, meaning we are at the maximum position. So at that maximum position, the velocity is zero, meaning this part here is zero. So mechanical energy is now 33 joules. So we have 33 joules here. So 33 joules is going to be equal to the elastic potential energy. So we know that elastic potential energy is just basically half kx squared. Okay? So now from here, we need to find the x value. So what will be our x value? So it's going to be 33 has to be equal to half. We know that the k is 1631.94. Then we want to find the x value. Okay, so what are we going to do? We are going to say 33 is going to be equal to, we have just to get that guy, it's going to be 1631.94. We divide it by a 2. So I'm getting my value as 815.985 x squared. So we divide both sides by the same value. Let me get rid of this. So we have this. So these they'll cancel. Even here we are going to have 819 this. So our x squared is going to be equal to, we have 33 divided by 815 point, we have 0.985. Okay, so I'm getting my 0.0404419. Okay, so I need to get the square root both sides. So what will be my x value? So I get the square root of this part. I'm getting my x value as 0.2. So at that point just before, it's going to be 0.2 meters. So this is how you work out some problem which involves simple harmonic motion. Okay.